to those who've got the work in for this week already. Looking through the ones that my class have put together, and I think Mr. Critchley's the same. It looks like people are really getting the hang of this. So that's really nice to see. Today we're going to look at some more like a mix of trig, but in some kind of application questions, so some worded question, and hopefully some shapes at the end. As always, we're very good with the rules, but just a reminder, video switched off, unmute if we ask, otherwise on mute, and using the chat for things related to today's meeting. We will, hopefully, everyone will need a paper, either a pen or pencil and a scientific calculator, so we can join in along at home. There are some questions I'm going to ask people to, well, we might do over the microphone. We might just get you to put your solution or your answers on the chat, see how we're going for time. I believe that is everything. So spot the mistake. A few people popped it in the chat, but essentially the mistake is, we look down here, we needed to invert sine. So take the inverse of sine of 0.9 in order to get the angle. We didn't, this person just took the sine of 0.9. Okay, so well done if you spotted that mistake. Right, let's get going. So our first question. A ladder that is 6 meters long is placed against the wall. It makes an angle of 34 degrees with the wall. Find A, how high up the wall it reaches, and B, the distance the base of the ladder is away from the wall. So on the right, you can see a diagram of this, which is not necessarily always going to be given to you, but in terms of these questions, one of the best things to do straight away is try to visualize what this is going to look like. I personally think drawing the triangles and visualizing how this is going to look is always going to help you, and it's always a sensible first step. Okay, so let's look at A. So for part A, how high the wall it reaches. So I'm going to draw my triangle. So I know my diagonal, which is the hypotenuse, is 6 meters. I know the angle that the ladder makes with the wall is 34 degrees. And looking at that, that's all the information I've got. I know that this side is the hypotenuse, this is the opposite, and this is the adjacent. And finally, for this, I want to see how high up the wall it reaches. Therefore, X, the side I'm trying to find, is going to be the adjacent. So then I look at what information I need and what part of trig I need to use. So I've got the hypotenuse, got the angle, and I want to find the adjacent. So I don't need the opposite. And as I'm sure we will be aware, that means that I'm going to use cosine, cap. And then from there, if I'm going to find A, then all I need to do, looking at my little triangle, is the cosine of 34 degrees multiplied by the hypotenuse, which gives me 6, which is 6 meters. Therefore, A, or in this instance, we've labeled it X. X is going to be equal to 4.97 meters. Okay, hopefully we're all happy with that. I would expect us all to be pretty confident with that now. We're then going to look at the distance the base of the ladder is away from the wall. Okay, so this poses up an interesting question now. So we've got our triangle again, 34, 6 meters. We know this is the hypotenuse, this is the adjacent, opposite, and we've now worked out that this is 4.97. Okay, so obviously this is a right angled triangle. This is what we're trying to find. There's a few different ways we could approach this. Obviously, we could use trigonometry. In the chat, could anyone work out maybe what other way we could approach this? thinking about it being a right-angled triangle.
We've got people saying Pythagoras,
Okay.
Pythagoras.
Perfect, exactly what I'm looking for. And I'm interested to know if anyone would argue that we should use Pythagoras here, or if we should stick with trigonometry. And if whatever their answer is, why? Anything there, sir?
Loads of people just saying Pythagoras. Yeah, use Pythagoras.
Okay. Can anyone maybe think of a reason why we wouldn't use Pythagoras?
Yeah, I've got a couple of people now saying use trigonometry because you've got a decimal.
Yeah, okay. What about the decimal though?
We've got a couple of people saying that Freya's saying Pythagoras is less accurate.
Okay, yeah, we're getting there. Why? Why is Pythagoras less accurate? Because it's not going to be less accurate as a general method. It just, in this instance, it might be less accurate.
4.97,
yeah,
which is the adjacent side, is rounded. From,
perfect. Exactly what we're asking for.
Rounded step in between. Yeah. Good.
Okay, so just a bit like when we use, we did those Pythagoras questions, and we had two shapes, and we had to use the side, and then we use the exact number for that side. This is very similar. This 4.97, not very well written, I admit, is a rounded number. So whilst we're probably going to get a relatively good answer, we won't get an exact answer. And that's something to look out for all the way through. And there might be cases where we need to use Pythagoras, because actually that will give us the most accurate answer. But anyway, we're going back, so we want to find the opposite. We've got the hypotenuse, therefore we're going to use sine. We're trying to find the opposite, therefore it's going to be the sine of our angle, which is 34 degrees, multiplied by 6, and our unknown value will be 3.36 meters. Okay, hopefully we're happy with that. That's a good discussion we've had about in this part B, and I'd like you to keep that in mind as we go through these questions. Okay, so this time I've covered up the diagram, but as I'm reading the question out, have a think about what you think the diagram will look like. So a boy gets his kite stuck in a tree. He knows that the amount of string let out is 28 meters, and the distance he is from the tree is 15 meters. So have a think about that in terms of what your diagram's going to look like. Find the angle X that the string makes with the ground, and B, how high up the kite is. So hopefully you'll have some sort of idea of what this would look like. Let's have a look. And hopefully, if you just click the hand icon, if you think that was kind of what you were thinking. Hopefully lots of hands.
Yeah, hundreds.
Hundreds. We've got 100 in the attending, have we? No one wants to miss the Hawker and Critchley meetings, do they? No. Okay, so the angle X that the string makes with the ground. So we're going to draw our diagram, our triangle. Always a good thing to do. So we've got 20 meters here, 15 meters here. Hypotenuse, adjacent, opposite. Okay, we are trying to find the angle. We've got H and A. Get rid of the opposite. And we can see here it's going to be cosine. And cosine of X is going to be equal to the adjacent, 15 divided by 28. And then to find X, we take the inverse of cos 15 over 28, which is going to be equal to 57 28.61 degrees. I'm putting it to 2 decimal places at the moment. The question hasn't asked, so I've just feel like that's an appropriate degree of accuracy. Okay, so in our mistake question right at the start, they didn't take the inverse of sine. In that case it was, but in this case it's cos, and that's always something to look out for. Some of us may, at this point, think about turning that into a decimal. I think people in this meeting should be happy with popping a fraction straight into a calculator. Okay, and move on. So the next part of the question is how high up the tree the kite is. So we're looking really for okay, we're looking for the opposite this time. Now, I wonder if in the chat anyone would be able to tell me maybe what they might do here. What might be more accurate? Any comments in the chat, sir? What might be more accurate here?
Do you want what method to use?
Yes, sorry. Yeah, I should have been clear there. What might be the most accurate method to use?
Yeah, Pythagoras now.
Yeah, and that's because we've been given exact values. 57.61 is rounded to 2 decimal places. So we've got the hypotenuse. We're finding a shorter side. So we're going to do 28 squared, subtract 15 squared to get the opposite. And that is going to give us, again, 3.559, which is equal to, if we wanted to put it into decimal places, 23.64 meters. Okay. So we've really got to identify when we need to use trig and when we need to use Pythagoras. Okay, can we get our pieces of paper ready? And I would like you, I'm going to give you a couple of minutes. I'd like you to have a go at this question. Have a read through it, think about what your diagram is going to look like. I'll reveal the diagram in about 20 seconds. But yeah, I'm going to give you about 2 minutes, and then we'll ask for some solutions and see if we agree with my solutions. If you disagree, that's absolutely fine. Just we'll have a discussion about it. Hopefully, we've all looked at it like that. Just another minute or so. Anything come in the group yet, sir?
What, for the answers yet? No, not yet. Just give me a bit more time, I'd say.
Yeah.
Yeah, got 2 or 3 answers coming through now.
Wonderful. Okay, we'll just give another 30 seconds or so, and I'll reveal the first one.
I haven't seen a correct answer yet, though.
You haven't seen a correct answer yet?
No.
Okay, interesting.
No. No. I got my first correct answer. I was being slightly picky, if I'm honest.
Yeah. So, can you see my screen?
Yep.
In terms of my answer?
Yeah, perfect. Yeah. Although,
Because
I might say yours is.
Yeah, I think I've made the same error. Obviously, on purpose to bring the point up. Actually.
Yeah, I agree. Yeah.
Okay, so we'll leave that one there for everyone. And then I'll give you just a little bit longer to have a go at the next bit as well. Okay. So we just talked through this first bit. So we've got our diagram. We've got the ladder that's 6.8 meters. It's leaning against the wall 1.4 meters away. And we are working out the angle. We use cosine of x is equal to the adjacent divided by hypotenuse. Take the inverse of cos. And we get x is equal to 78.19 degrees. However, as Mr. Critchley has pointed out, the part of the question, calculate to the nearest degree the size of the angle. So there should be one more step, it should be 78 degrees. So if you were maybe going to say this was worth 3 or 4 marks, you've dropped a mark, well I've dropped a mark there as well, if you haven't gone to the nearest degree, which would obviously be quite frustrating because you've displayed you know the answer, however you've just missed the mark by not rounding, and I'm pretty sure I'm going to miss a mark on the next one as well.
Well, weirdly, I guess for the next one, I still haven't seen a correct answer yet, which is really interesting. I mean, there's 20 answers here, but I still haven't seen a correct one, which is interesting. So it'd be interesting. Someone will get there in a minute, I'm sure. But
Oh,
anyway,
I think
no, go on, show them. That's fine.
I think I might have got full mark for this as well. Full marks.
Yeah, well done. I can see a few correct ones now. Yeah, good.
Are we agreeing with me?
Yeah, nice.
Nice to see.
6.65 meters would have been fine as well, wouldn't it?
6.65 meters. Would it though?
Yeah.
To the nearest centimetre?
Well, that is the nearest centimetre, though, isn't it? 6.65 meters.
Have you given it?
You've given it to the nearest centimetre. You've left it in meters, but it's still.
Yeah, you're right. Yeah.
To the nearest centimetre. So either 6.65 meters or 665 centimetres. Both of those would be correct.
Okay, I'll take your advice on that one.
But this is fine.
So that's another one where the second part, we're making a decision between trigonometry and Pythagoras, and because we've been given the side, the hypotenuse, and the adjacent, that is Pythagoras to use in this instance. We get an answer of 6.654 and so on. We are then either taking it to 2 decimal places, because as Mr. Critchley points out, that is essentially giving it to the nearest centimetre, or you can convert it to centimetres and then round from there. But either way, we should have 665 centimetres or 6.65 metres. Okay, hopefully we did okay on that. Right, a man stands on a cliff, M, and sees a boat out to sea, B. The angle of depression from the man to the boat is 31 degrees. The height of the cliff is 25 metres. Find the distance from the boat to the base of the cliff and NB. Can someone in the chat, or anyone in the chat, talk to me about what the angle of depression means? Angle of depression. I wonder if that's something people haven't heard before.
Or you can put your hand up, I guess, as well and tell us if it's
Yeah,
different
absolutely.
type.
If I also maybe add in that we've got an angle of elevation and an angle of depression.
The angle going down, how far down the angle is, the angle from him to the boat. He's stood on a cliff, so the angle will be down slightly.
Okay, yeah, well, I think we're not far off. So if we say we've got our horizontal, that's meant to be a straight horizontal line. Our angle of elevation, with anything going up from the horizontal. Our angle of depression, anything going down from the horizontal. So, especially in maybe when you come up to more mechanic style questions, when you've got the edge of a cliff and everything like that, that's when we can really start looking at angle of depression. But yeah, in these trigonometry questions as well. So we've got our angle of depression. M is standing on the edge of the cliff. B is where the boat is at the bottom in the sea. Okay, but once again, we're just going to draw our triangle. So we've got M. Now we need to be careful here, because the angle we've been given is 31 degrees. So the angle that we need to use is what makes up the right angle, which is going to be 59 degrees. And then I know that this is 25, not 25 degrees, 25 meters. Then we label our triangle for H, adjacent A, and the opposite. Okay, so the first thing that we need to find is the distance from the boat to the base of the cliff. So this would be the base of the cliff here. So we're trying to find the opposite. We have the adjacent, so we're going to get rid of H, and that is going to mean that we are going to use tan. If we're trying to find the opposite, then we are going to do tan of 59 degrees. Again, I'm using 59 degrees. I'm not using 31 degrees, multiplied by the adjacent, which is 25. And that gives me an answer of 41.61 meters. Okay, so that is going to be my opposite, or the distance from the boat to the cliff. We're then going to find MB, which is the hypotenuse of this triangle. I think I'm just going to rub out this solution. Hopefully everyone's had enough time to see that. So for part B, I want to find MB, so I want to find, where are you? The hypotenuse this time. Again, I've worked out though the opposite. However, it's not going to be, it's rounded, therefore I'm going to use A, which was given, and the angle, which was essentially given as well. Therefore, I'm going to be using cosine, and I want to work out the hypotenuse, and the hypotenuse is going to be 25 meters divided by cosine of 59. Therefore, H is going to be equal to 48.54 meters, and that makes sense because it's longer than the opposite. So a real quick check to make sure I've done something correctly is that the hypotenuse is the longest side. Okay. Hopefully we're all okay with that. Anything in the chat, sir, or are we okay to move on, do you think?
No, really good. Some good definitions of the angle of depression in the end, but yeah, all good.
Wonderful. Okay. Right, so now we're gonna have a look at two more worded questions, and then we'll move on to shapes for the second part, or the final part. We're just involved in some bearings here, which is interesting, always good fun, because these sorts of questions it's nice to be able to imagine them. So we've got a helicopter. It leaves point A. It flies 40 miles, which is exactly that amount that I've just drawn, east. So east, we're going to be moving to the right. Then the helicopter flies 10 miles south to point B. Work out the bearing of B from A. Okay, so first of all, we've got our right angle triangle, because we've got east, then south, and we're going to work out this angle here. Okay, I'm going to do exactly the same. I've got H, I've got the opposite, and I've got the adjacent. As we can see, we've got the adjacent and we've got the opposite. Therefore, we're going to use tan TOA. We want to find out tan of x. Well, we know that tan of x is equal to 10 over 40. Therefore, x is equal to the tan, or the inverse tan of 10 over 40, which is going to be equal to 14.04 degrees, roughly. Now, am I finished? Am I finished? Worked out x, so I've worked out the angle of A to B, unless someone wants to tell me something different. Anything coming through, sir, either through the chat or hand waving?
Need 3 digits for bearings.
Okay, yeah, fair enough.
It's not a bearing.
Maybe expand on that. So, interestingly, people are highlighting, I think there's 3 laws of bearings that we would use, or 3 rules, maybe. One of them is that they're always 3 digits. So,
yeah, and we've also now got the answer of 104.04.
oh, I like that. Does that person maybe want to expand on why?
Yeah, could L. Williams unmute themselves, maybe, if you don't mind?
Yeah, that'd be great.
Because it's from east, don't you have to make it up to north? So you'd have to add 90 degrees.
Perfect. So, work out the bearing of B from A. Well, that means from starting from A, and we go to B. And a bearing, we always start from north. Okay? So, we've got this part of the bearing that we need to add on 90 degrees. Therefore, the bearing of B from A equals 90 plus 14.04, which is going to give us 104.04. Thank you very much. That's really good. Was it Ellie or Eli?
That was Lola, I think.
Oh, it was Lola. Oh, thank you, Lola. Sorry, I thought you said. Okay, so hopefully we can see why we've got to that point. And now time for me to have a sip of coffee and you to have another go. So a similar-ish question. draw the diagram and then try and come up with an answer. Hopefully we'll all not make the one mistake. So I'm not expecting necessarily anyone to have it yet, but once you've got your answer, you make sure that you post it on the chat. Okay, got one through there, I think?
Yeah, I'm happy with that.
Good. Yeah, I like that. Okay, similar area, lovely.
Yeah.
Yeah, I think we seem to be in agreement.
I'd like someone else to write down another 2 digits just to prove they're not copying from the person above. 4 decimal places, please. Yeah, good, nice. Kind of.
Okay, so as you can see, there's my lovely little boat.
Great boat.
At the bottom.
What's that coming out of the chimney? Is that steam?
Yeah, it's steam, yeah.
Yeah, I thought so, yeah.
Yeah, it's a very nice boat. The boat sails 55 kilometres due west and then 30 kilometres due north. So we create our triangle. We arrive at the oil rig. What is the bearing from the oil rig? The oil rig from the port. So once again, we are aiming to calculate this angle in our triangle, but we need to recognise that we start from north. Therefore, we've got 270 degrees to add to that bearing. Good, well done. Okay, so those are the kind of worded questions where we have to visualize what we're looking at, create our triangles. But now what we're going to do is have a look at some questions where we are given some shapes and we have to apply this to apply trigonometry and maybe Pythagoras in order to find this value. Okay, so in the drawing on the right, ABCD is a square. We've got AP, which is equal to 5 centimetres. We've got QC, which is equal to 7 centimetres. And we've got PB, which is equal to 12 centimetres. So the first thing we're going to do is find the size of the angle marked X, and straight away I can see we've got a triangle which is in that top part of the shape, and we know that that is 12 and that's 5. We're looking for X, we've got our hypotenuse, we've got our opposite, and we've got our adjacent. Therefore, we're going to use sine, and we know that the sine of X is going to be equal to 5 divided by 12. Therefore, X is going to be equal to the inverse of sine divided by 12, which gives us an angle of 24.62 degrees. Okay, so we've just got to identify our right angle triangle and go from there. Okay, let's have a look at part B. So this time we're looking at AB. So AB, we've got exactly the same triangle, and hopefully from our previous discussions, we can see that actually the correct thing to do here would be to use Pythagoras. We could use trigonometry, but because we've rounded, once again, labouring the point, because we've rounded, it's much better to use Pythagoras. So we've got the hypotenuse, subtract the opposite, because we've got a shorter, we're finding a shorter side, and that will give us root 119. And for now, I'm going to keep this as root 119, because once again, we might need to use it for future questions. Okay, and then going to have a look at the length. So what I think I'm going to do is I'm going to rub out these bits. So let me just put them on the diagram just in case I need them. What was this? 24.62. Okay, so we're going to work out now. Next part, I'm going to change to blue just for fun. We're looking at DQ. Now, we could start thinking about using trig. However, we can also take the fact that ABCD is a square, and we know that AB, which is one side of the square, is equal to root 119. Therefore, DC, the opposite side, is also going to be equal to 119, root 119. Therefore, DQ, which is what we're trying to find out, is going to be DC subtract QC, which we've been told is 7 centimetres. So DQ is equal to root 119 subtract 7, which if we were going to give it, we'd have to actually leave it in that form for exact form. But if we were going to give it to 2 decimal places, it would be 3.91 centimetres. D is a very similar question. So this time we're looking for PD. And if we have PD, well, once again, it's just going to be, I'm not going to write out the side lengths, but the full side is going to be 119. We subtract 5. Once again, if we wanted to do it in exact form, we'd actually have to just leave it as root 119 subtract 5. Say we were going to use that for future calculations. So 5.91 is equal to PD. So in these questions, I guess the automatic thing sometimes is to try and go straight into Pythagoras or trigonometry, but sometimes we just need to look at the properties that we've been told in the shape in order to work those out. Okay, final part. Now, I think we could probably get the angle of BQD in a few different ways. So BQD is going to be this angle here. And I'm sure there's lots of different ways to do this. However, what I've decided to do is, and I believe this might be the easier way, the most efficient way. Mr. Critchley, whilst I'm doing this, if you want to see if you think there's a more efficient way that I haven't spotted.
Okay.
I'm going to do this triangle here, B, C, and D. I know that this is 7 centimeters. I know that this is root 119, and I'm looking for this angle here. So I've got my hypotenuse, I've got my opposite, and I've got my adjacent. I've got these two. So I know that tan of x is going to be equal to the opposite, which is root 119 divided by 7. Therefore, the inverse of that is going to be equal to 57.31. However, I'm not after this angle, which is what I've worked out. I'm after BQD, so I need to do BQD is equal to 180 because it's along a straight line. Subtract 57.31, which will give me 122.69 degrees. So that's how I've worked that one out. I think there's a few different ways, but I think that method maybe involves the least steps, unless, Mr. Critchley, you've noticed something a lot more obvious.
No, I think that's the most efficient way of doing it. I really like that. Yeah.
Yeah, because otherwise you're going to have to start doing trig on a few different triangles here before you look at these. So yeah, that would be my way, but I'm sure you could get to it in a different way. Okay.
Yeah, nice.
So as you can see, I'm identifying different triangles within the shape. I'm using the properties of the shape, and I'm thinking about whether I need to use trig or Pythagoras in these right-angle triangles. Okay, your turn. So have a go at this one. So we've got calculate the angles of BF, AB, and AD. You've been given some information about the diagram. So just another couple of minutes there. Did I make a mistake on one of the letters?
No, not really. Minor.
I just wanted to see if they were still all listening.
I agree.
Always thinking. I think by sheer luck, we might actually be pretty perfect on the hour of the questions we've got for Dan.
Yeah, perfect. Yeah. No, that's good. Very good.
So obviously, it's planned all along. just a little bit longer. Okay, in the interest of time, I'm just going to start talking through these questions. So we're going to find BF first. We've got that top right-hand triangle. We were told that BCF is, or angle BCF is 36 degrees. We were told EF is 4.7. I've used the fact that CDF is a square, so that FC is going to be equal to 4.7. And then I've got enough information. I know that I need to use tan. I know that opposite is tan 36 multiplied by 4.7. So I get 3.4 centimeters is equal to BF. Okay. And then move on to finding AB, which is the larger triangle on the left-hand side. Again, I do my diagram, put my bits of writing on there, or bits of information, I should say, and I know that, well, 4.7, I've worked out BF, which is 3.4. Now, you could argue that I should use the exact value of BF here to add to F or FE, EF, sorry, in order to get that, but I've got 8.1 where I add them together. I've got the angle, which is 28 degrees, which was given. I can then work out the hypotenuse, which is going to be 8.1 divided by sine of 28. And I get 17.3 centimeters as my hypotenuse. And then the final thing I need to work out is AD. So once again, I've got my values of 17.3 and 8.1. I'm going to avoid, so I want to work out AE first. I'm going to avoid using Pythagoras here, because that then gives me two sides which have been calculated and rounded. So I'm just using 8.1, because that's my original one, so not two lots of rounding to get 17.3, and the 28 degrees which was given. I want to find the adjacent. I've got the opposite and the angle, so I'm using tan. 8.1 divided by tan of 28 gives me 15.2. However, that is AE, and in order to get AD, I need AE, but I also need ED. I know that's 4.7 because it's a square. Therefore, AD, that should say D, is equal to 19.9. If you use the exact value of EF right at the start, which is, or whatever we worked out right at the start, which is absolutely a good thing to do, then you might have a slightly different answer. In questions like this, there will be a small range or error range in terms of decimal points, but it's always best to use the full one. Anything in the chat, Sarah, or do you think we're okay to move on?
All good, yeah. Carry on, I think.
Okay, right, I've got two more questions, so I'm moving slightly quicker. Right, so KLMN is a trapezium with LM parallel to KN. So we've got all the information here. Calculate the perpendicular distance between the parallel edges. So essentially what that means is this distance here. Okay, so we've got our parallel edges and we are really finding the height of the trapezium. Using the information we've been given, I'm straight away looking at this triangle here, and I know that LK, or KL, sorry, is 10.7, and I know that this angle here, LKN, this angle here, is 58 degrees. So I've got my hypotenuse, got my opposite, and I've got my adjacent. I want to find the opposite, so I use sine I use sine of 58 multiplied by 10.7, which is going to give me the opposite, and that gives me 9.07 centimeters. And again, you might want to try and, for future parts of this question, you might think, well, I want to use the exact value. If you aren't going to use the exact value, it might be better to go to a few more decimal places than the two that I've got here. Okay, for the second part, we're going to look at calculating the area of the trapezium, and we now have enough information in order to do this. So the area of the trapezium is the two parallel sides added together, which we have been told are 8.4 and 19.6, multiplied by the height, the perpendicular height, which we worked out to be 9.07. Again, you might want to use some more accuracy there, and we've either multiplied all of that by half or divided by 2, whichever way you want to say it. And if we pop that into that formula, we get an answer of 126.98 centimeters squared. And that's going to be the area of our thing here. So I've worked out this is 9.07. Is there anything else I need to add on to the diagram? What's that? 10.7, 19.6, and 8.4. So I'm just going to get rid of the information here. And our final question is the perimeter of the trapezium. So actually, as I'm sure you know, the perimeter of the shape is the distance around it. MN is the only side that we need to find. However, before we can find, we haven't got enough information in this triangle here in order to go straight to finding MN. There's a few steps that we need to take first, and that step is we need to, what am I doing here? We need to find, got 9.07, and we need to find what this length is here in order to then find the hypotenuse. So I draw my original triangle, which is going to be 10.7, 9.07, and 58 degrees. Once again, I'm going to use trigonometry because these two values were given to me, and I found this one. So the opposite I don't want, and I want the adjacent. So I've got cosine, and I know that I want to find the adjacent. Therefore, it's cosine of 58 multiplied by 10.7, which gives me an answer of 5.67. I then want to think about, well, if this part is 5.67, this part is 8.4, because I know that from this value here, then I can work out what that final bit is, and I just do 19.6, subtract 8.4, subtract 5.67, and I get 5.53 as my answer, and therefore I can now work out the hypotenuse. Again, so if you think there's a more efficient way, do say, but at the moment I'm thinking this is the way I'm going to do it. 9.07 is my height, 5.53 is my adjacent, and I don't know the angle, therefore I'm going to use old friend Pythagoras. 9.07 squared, find the hypotenuse, so we add, and that gives me a value of 10.63, I believe. 10.63. Again, the more you can use decimal places here, the more accurate you will be, but there will be an error range for this. And finally, I'm going to add up all of my sides, so the one I've just calculated, plus 8.4, plus 19.6, plus 10.7, in order to find the perimeter, and that gives me 49.33 centimeters. Okay, so that final part, quite a long-winded way. Again, there'll be different ways that you could have calculated that. However, that's, I think, the most efficient way. Okay, so it is 3 minutes to go. I've got one question for you to have a go at. I'm happy, but we'll go over slightly, but I'm happy for people if they think they've seen enough or they're feeling a bit, there's been quite a lot of information there again, to leave now. If not, a couple of minutes, let's have a go at this last question, and then we're done. So if you do want to leave now, you're welcome to, but hopefully everyone's got enough in them to do one last question. Getting the impression quite a lot of people are taking the option to leave. Worth a chat.
Maybe. Only a few have left. Do you need to know the area for the formula for the area of a parallelogram here?
Yes.
Okay. Yeah.
Quite a lot of people who said thank you on the chat are actually still in. So
Yeah, still got a few to go through it, I reckon. It's quite a nice one. Quite a nice question, this one.
Thank you to everyone who said thank you. Pleasure. Just a little bit longer. Not that large. How is Sam Robinson removed?
Yeah, I don't know. Is he? But Sam's not in here anymore, is he?
I'm not sure. I haven't looked at the.
Yes, Sam. Okay.
Yeah, I think it goes without saying that we're not removing people from meetings. But we'll trust that you didn't need to do that.
Yeah. Don't do that again.
One more minute. Interested to I've rushed the part B, so I might have an So did you recorded this, didn't you?
Yep.
Brilliant. Thank you. Okay, maybe we've got on to the first bit. It's the area of the parallelogram. Hopefully we recognised in order to get the area of the parallelogram, we needed to get the height. Therefore we created our triangle. It's B, so the I did the left-hand side. We know that AB is equal to 3.8. We know that BAD is equal to 48 degrees. Therefore, we need to use sine of 48 multiplied by 3.8 to get our opposite, which gives us 2.8 ... That signifies lots of different, lots more numbers. In this example, I did use the exact values. So I did area of 2.8 going on, multiplied by 7.9, which is the length of the parallel, the horizontal line, and that gives me 22.31 centimeters squared. So hopefully we were in agreement with that. Now, initially for this second part, what I tried to do was I tried to create a triangle like this. So I split this in half, but hopefully we can recognize straight away that this diagonal is not going to bisect this parallelogram. If it was a rhombus and all the sides were the same, it would bisect it because we create two isosceles triangles. But for a parallelogram, we couldn't do this. So I wonder if anyone also made that mistake. Absolutely fair enough if you did. But again, in these shapes, these questions on shapes, we need to be really secure on our understanding of the properties of shapes. So the way I did it, and I'm hoping I did this literally a couple of minutes beforehand, so I'm hoping I've got this okay. I worked out what the adjacent was here, which is again 3.8 and 48 degrees. Used cosine of 48 multiplied by 3.8 in order to get A, which is 2.5. I've used the dots again to keep it exact. So I've worked out this in order to create this triangle here. So this value here is the same as this value here. And then if we go down, I've used the exact value of, what have I done? Yeah, so I've done this length here, which we know to be 7.9, plus this value here, which we worked out here. Hopefully this is relatively okay to follow. And I always have to forget that you're not in the room with me, so things I'm pointing at are not on the screen. And then we worked out the height earlier on. So this part we know as well, which all comes together in order to make this triangle 10.4 and 2.8. And I don't think I've used the exact values this time, I've just rounded. And I used Pythagoras in order to find the diagonal AC, which is 10.8 centimeters. And again, we can see that this is our longest side, so whilst that doesn't mean we're definitely correct, it gives us an idea that, well, that's one checkpoint, I guess, ticked off. Okay, so that's the end of today. Hopefully you did all right on that bit, and hopefully you're happy with what we went through. I think that our basics of trigonometry now seem to be pretty strong, and that was the chance to apply it to maybe some slightly different questions there. Just while we've got you here, we do have this week's task ready in the next few days, needs to be submitted, and make sure please that you mark it. Myself and Mr. Critchley don't enjoy writing please mark on your feedback, so if you could save us typing that out, that would be lovely. We have noticed a few people maybe dropping, not many, but a few people dropping off in terms of getting the work submitted. We've got just under 2 weeks now, or exactly 2 weeks today, in fact, for the rest of the term. We completely appreciate it's been a very strange final third of the year. However, we've got 2 weeks, so let's really push, make sure we do really work hard in this last 2 weeks, get everything in. If you can't get something in, email myself and Mr. Critchley, and let's really have a strong finish to the year, so then we can have a well-deserved break over the summer holidays. So we are expecting everyone to complete it. I'm going to spend this afternoon having a look at who's still outstanding in my group for last week and really start to think about chasing the people for this week. And I know Mr. Critchley feels very similar. Okay, so well done to those who've done it. Thank you for joining today. And let's just make sure we have a nice finish to the end of the term. Monday, we will be running a Teams meeting. Mr. Critchley will be doing something on 3D trigonometry, and then we will do a worksheet for the rest of the week. Okay, sir, anything to add? Or?
No, thank you very much, sir.
No problem. Okay, so if you'd like to start leaving now, pleasure as always to have you with us, and this will be going up on the VLE if you need to rewatch, or if someone else asks if it's coming on. Okay, so if we can start leaving now, that'd be great. Thanks a lot, guys. You're more than welcome.